Hi, welcome back. This is where we stopped in the previous video. We have created our 2D mesh and we have also specified our boundary condition lines. In this video, we are going to specify those boundary conditions, or you can say we are going to create the unsteady flow file. So to create the unsteady flow file, you can either go to edit and say unsteady flow data, or you can push this button here that says view or edit unsteady flow data. Either way is fine, so I will go to edit and unsteady flow data, and this is what you see. So what you see here are the three boundary condition lines we have specified. So we have the lower Wabash, we have Tippecanoe, we have upper Wabash. So let's go ahead and do the Tippecanoe boundary condition first. So to specify the boundary condition, you click the cell next to the boundary condition line. So we are going to specify the flow hydrograph for Tippecanoe County. And you can see once you click here, you will see what type of boundary conditions you can specify. You can either do stage hydrograph, flow hydrograph, rating curve, or normal depth. Since this is an upstream boundary condition for Tippecanoe, we are going to do flow hydrograph. So click on flow hydrograph, and this is what you see. So the first thing we have to specify is the time interval. By default it is 1 hour, so we are going to keep 1 hour. But if you are creating a model for a observed hydrograph, you have to make sure that you match the time interval of this input file to the time interval of the data you have. Okay, so this is the first thing we are going to do. Keep the default 1 hour. The next thing is the simulation time. So we are going to say fixed start time, and we are going to specify current day. So you can just use the day that you have, which is today. So in my case is 17th of August. In your case it may be something different. So I'm going to click on today and say OK. And the time we are going to start at midnight. So this is going to be 0000. Okay, and what we are going to do is we are going to specify a hypothetical hydrograph that lasts for 16 hours. So I'm going to specify the hydrograph as a triangle. So the initial flow is going to be 100 CFS. It will peak to 2000 CFS at the midpoint, and then it will come back to 100 CFS. So I'm going to say 100 CFS at 0 hours, and then I'm going to say 100 CFS at 15 hours, and then at the midpoint, which is 8 hours, I'm going to say 2000 CFS. And once you specify these 3 points, you can say interpolate missing values. So I'm going to click on that, and you can see it interpolated the values between the 3 points I specified for the triangle. Okay, so the first thing is the time interval, the second is the start date and time, and then we specify the hydrograph. And the last thing we have to specify is the energy slope for the boundary condition line, and we are going to specify that as 0.002. Okay, and this is all we need to specify for the flow hydrograph. Now you can also click on the plot data to see how the hydrograph looks like. So I'm going to do that, and you can see we have our triangle here. So it starts at 0 hour at 100 CFS, then it goes to 2000 and comes back to 100. Okay, so if you are satisfied with this, so you can close. So this is the graph. You can also see the table and the graph together by using this button. Okay, so I'm going to close this and say OK, and we have the flow hydrograph for Tippecanoe. Now let's also go ahead and do the flow hydrograph for the upper Wabash boundary condition. So the same process, so I'm going to click on the cell next to upper Wabash, flow hydrograph. Our time interval is 1 hour. Our start date is going to be again current day, starts at 0000. Then in this case, since this is a bigger river, we are going to specify our initial flow as 2000 CFS. Then at 15 hour we will specify as 2000 CFS, and the midpoint is going to be 15,000 CFS. So midpoint is 8 hours, so this is going to be 15,000 CFS, and then we will interpolate missing values, and we are going to specify the same energy slope for the boundary condition line. So this is 0.002, and then if you want you can plot the data and see. So it starts at 2000, goes up to 15,000, come back to 2000. Okay, and say okay. And finally we have to specify the downstream condition for the lower Wabash. So click the cell next to the lower Wabash boundary condition line, and for the downstream boundary condition we are going to specify normal depth. So this is going to be our frictional slope of 0.002, and this is defined as the slope of the energy grade line, and it is used as the downstream boundary condition. So basically it represents the slope of the water surface that the program will use to calculate the water surface elevation. So I'm going to say okay, and then we are going to go to file and save our unsteady flow data. So go to file, save unsteady flow data, and then it will ask us to provide a title, and the title is going to be unsteady flow data for Wabash Tippecanoe confluence, or we can just say Wabash Tippecanoe. So the title is unsteady flow data for Wabash Tippecanoe, and you can give whatever title you want, but you can see it has already given a file name, and it will save with the extension that starts with U. Okay, so I'm going to say okay, and then you close. So you can see in the project window we have the project file, we have the geometry file that we created earlier, and in this video we created the unsteady flow file. So we have all the information now. The final file that we will create is the plan file to run the simulation, and we will do that in the next video. Okay, so this is it for this video, and I'll see you soon in the next video where we will run the simulation for the Wabash Tippecanoe confluence. So see you in the next video. Thank you. Bye.